Myself, Shiva. I lead the backend test platforms team. A little bit introduction about myself. Been with Uber for almost 3 years. This is my third product. My first product was building a driver compliance platform, basically trying to make sure drivers are compliant based on whichever geography you are in. My second product was building a workflow platform. For example, if you look at microservices, there's a need for a database and a persistence queue. What we are thinking is, can we eliminate both of those in the microservices world? This is more or less similar to Amazon's SWF. And right now, I'm trying to work on the test platforms product. A little bit higher goal for what exactly we are trying to do at the test platform is today we are, as Prabhu mentioned, we have 4,000 microservices. And the bigger challenge comes in is how do we keep up high reliability and higher uptime on our apps, for example, rider apps, driver apps, eats, and restaurant apps. For example, in spite of failures, I can complete my trip. And if I ordered any food, I can get my food delivered in spite of data center failover. I'm going to talk about some of the challenges we have. This is one graph how Uber growth looked like back in 2004 and 2016. As you kind of notice, traffic is quite peaky. We kind of notice that there is a weekly spikes, and during certain parts of the day, it's kind of just goes up. And there are some parts of the day where it comes down. Some of the observations, if you have noticed, there are two kinds of slots in a year where pretty much all of our services are excised to the peak traffic, the Halloween and New Year. The other interesting observation is whatever the current peak traffic for my services, it's going to become normal in 3 to 4 months, which means we are in continuous problems of planning for the capacity, throughput, and error latency. And 3 to 4 months, we are back to the same problem again. We were wondering how to break this problem. The other thing is on 2014 Halloween, we had a pretty bad outage. And that resulted in two important products internally at Uber. I'm going to talk about a little more. One of them is Hailstorm, which is our load testing framework, services, and tools. We kind of today use that to load throughput or performance any microservice. We also use that to do a set of services as well. And we also use that for data center capacity planning. The other thing that came up is the reliability platform. Internally, what we call is UDestroy. It is our kiosk platform, which is built on kiosk principles, but we went a little bit ahead. I'm going to talk about that as well today's presentation. Yeah, some of the core challenges that we have. This is the one which I tried to mention earlier. If I'm a service owner Foo, I need to a little bit worry about what's going to be the peak load that looks like this week. How am I going to manage for next few weeks? And what it looks like for 3 more months. What we ended up is we actually built quite a lot of tooling where you can actually do a lot of load testing against your service to the point where today, if you have any of your commit that landed, you can pretty much configure to run the whole load and performance testing to get a feedback that if anything has regressed from what your service has already promised. And we also use the same set of tools for forecasting load. For example, if you're heading into Halloween or New Year, we kind of do better planning so that we have enough capacity for 3 months or 6 months. And to the point, pretty much every microservice owner today is familiar with it. The other thing is we also kind of looked at last year outages and see what are some of the biggest problems. And we correlated that a lot of them happen, around 70% of them is because of the code change that we make. And why is that so complex? Today, for example, if you take a driver, go online, just one single endpoint would end up talking to 100 microservices. Now, if I'm a service Foo, if I had to test anything in the business scenario, which is actually talking to at least like 300 microservices, how can I make sure my change does not break any of these microservices before I can actually commit the change into the master branch? And the challenge becomes, how do I get the feedback much earlier in the development cycle, for example, before I send out a PR request? Little later, I'm going to talk about some of the challenges there. Some of the bigger challenges we have there is, how do we bring up the entire Uber view on my laptop in order to evaluate whether my change is really not breaking any of the stuff? The other thing is data center failover. Uber owns its own data centers. We have a couple of data centers. It has its own challenges, good and bad. Good, you can do a lot of optimizations all the way to the bits and hardware. Bad, now you have to manage your hardware and the whole stack itself. A couple of years before, we had a data center meltdown on West Coast, and that kind of resulted a lot of people not able to take the trip or complete the trip. What we ended up after that is we kind of built a whole set of services, tooling, everything, so that once in a week, either Tuesday or Wednesday, we kind of simulate the entire data center failure across Uber, and we make sure none of the business flows are broken, none of the dev flows are broken. It's kind of like guaranteed that pretty much any service owner, by design, they have to make sure their service is all active across data centers. Even if they forgot to do it, in a week they'll know whether their things are broken or not. Yeah, so today my main focus for today is I wanted to talk about what are various frameworks that we have. What we call this is test framework pyramid. The idea of the pyramid is industry standard, but the idea is at the bottom of the pyramid, you're kind of developer is spending a lot of more time to author the tests and also to write the number of tests. As you go up in the ladder, you kind of spend less time in both of those directions. Unit tests, this is where something we don't do anything specific. We pretty much use most of the open source. So pretty much same as how do you test your composable piece of code. Integration tests is where things are slightly complicated. I'm gonna come in a moment to talk about what are the tools we have and how do we actually do the integration testing. Up in the ladder is the performance and load testing. This is where we kind of use a lot of tools internally to figure out how does your service look like with the QPS, error rates, how does a set of services look like, how is a business functionality look like. Resiliency tests, this is where we have one more talk which goes in detail, but the idea of this is we try to introduce failure disruption scenarios on your production services so that the service owner can learn more about the service because it's in the real time and you can catch a lot more scenarios that you normally will not be able to see them. External and public API tests. External tests are our third-party developer API tests. For example, if you're trying to build a coffee app and you want to request for an Uber ride, these are the applications, these are the APIs which we kind of expose. We wanted to make sure they never go to whatever availability, like 3 nines or 4 nines, whatever we promise. It never goes down below certain error rate. We wanted to make sure none of these are broken outside the Uber traffic, Uber data center itself. So in a moment, I can talk about what we do there. The public API tests are the endpoints that we kind of expose, but pretty much consumed by our driver apps, Eats app, and Rider apps. We wanted to make sure if there is any problem, we know it much earlier than anybody else notices to make sure we guarantee the 3 nines or 4 nines. Manual tests is pretty much unheard in the backend services. I wanted to mention there are some important front-end visualizations that you could do with this. We have something called internally Uber Studio where you can actually go to a particular city. For example, 3 p.m. in Seattle, you can go to a particular location, you can drop a couple of cars, couple of riders, couple of drivers, and see how the whole flow looks like. This would be super cool for some of the edge cases where it's pretty hard to do any automation. Unit tests and integration tests, whenever you make a code change and you actually send out a PR, we kind of make sure we run the unit tests. Once you actually land the change, and later once you integrate into master, we still run the diff changes. We similarly run the integration tests in all the 3 phases. The integration test here is whenever it's touching more than 2 services, we wanted to make sure we run all of those integration tests before it lands into your master. We run performance, load test, resiliency test on your master build. For example, while it's progressing to staging or production, on your commit, you can make sure that nothing actually regressed in your load testing. And the other ones, external tests, manual public API tests, they are pretty much run on the release builds or on the production areas. So I'll briefly touch upon the unit tests, what we do. As I mentioned earlier, we don't do nothing specific inside Uber. To give a little bit of overview earlier, we mentioned there are 4,000 services and there are almost 12,000 repository, which means like per developer, per service, there are almost 3 repos, which comes up with its own challenges, good and bad. With the micro repository world, your entire test selection is very limited to a service. It's going to be in terms of hundreds, but not thousands, which means you'll not run into latency problems, flakiness, various other things. But there are other problems that comes in. How do you do version conflict? For example, if you have one single library and there's 300 services using it, you would have to know what's the dependency chain, how do you actually upgrade those. So in that way, we are also experimenting a little bit with the monorepo world. How does it look like to put all these 4,000 in monorepo? Maybe at that point of time, the test selection flakiness will become important. For now, we don't have that problems yet. So most of our backend services are built on Go and Java. Majority are in Go. It's a super cool language. And most of the frameworks that we use are out of open source on the GitHub. The Mockery frameworks pretty much we use. We pretty much run them locally, run in CI as well to get the same feedback. We run them in parallel. It's probably not that important, but in the monorepo world, it becomes very important about the latencies. Right now, it's in the order of minutes, so nobody complains. And we also get the various code coverage numbers, as you can see. The integration test, right? So today, the workflow looks like, for example, let's say I'm a service owner, I modify a change or I add a feature. Now, either I add an integration test or I have a lot of integration tests that kind of test my business flow, right? And I want to test them before I actually send out the PR. The problem there is, let's say, if you're requesting a ride and trying to complete a ride, there is a whole graph of services that need to be navigated. Now, if I'm somewhere in the middle of the node and I'm trying to test my change, now I'm trying to call downstream services, let's say 50 or 100. Now on my laptop, how do I actually get all of those dependencies up and running? And how do I isolate all of those for that particular change? Now the downstream services can go all over the graph and they end up calling the same service, which we call upstream dependencies. Now, how do I test my change in order to get even the upstream request to make sure none of those are broken before I send out PR? Which means I kind of have to, whatever the service I have, we need to somehow stitch together in such a way that you have the entire Uber view of the world isolated for the diff so that you can actually get a good enough feedback. And some of the challenges is how to bring the entire stuff on the local laptop. Once I actually send out the diff, once it lands to cloud or Jenkins environment, how do I get the whole world into that Jenkins environment so that I can evaluate that nothing is actually broken on the CI? And once you commit the change, now it goes through staging and production. And maybe there, the world could be shared with the rest of the production world that you have. And some of the philosophical questions here is hermetic testing, which is like industry famous. The idea here is, how do we bring up the entire dependencies on one single box to isolate all its dependencies and not have any of the network and do my evaluation of the changes? And the other one, which is quite experimented inside Uber and pretty much every service uses, is how do we use testing again as staging our production? Some of the challenges here is how do you get the isolation of any of your peripheral systems or in-between systems? For example, if you have a compute, if you are getting a test request, you don't want to share with your production request because you don't want to get throttled or anything else. And the same thing at network level, if you're having a test traffic coming, you don't want to affect your production traffic. How do you get your network isolation all the way up to routers? And even more, the problem gets accelerated when you have the data. For example, I have Cassandra or MySQL. Now I'm getting a test request and production request. How do I isolate my data for these two? And pretty much every system uses Kafka, in-memory Redis cache, and you have a whole lot of in-memory objects. For example, I have a dictionary of driver IDs, but I don't want to get polluted that with the test traffic, right? So which means you need to have isolation all the way at the request level. And how do we actually make this happen? One extreme you can think about is having everything duplicated. That comes with a lot of cost of hardware. And the other extreme is sharing everything, which means you have to write super intelligent code not to introduce any bugs. And it is slightly harder to get it right. So getting throttled on S3 systems. We don't use S3 for internal testing, but the same problem exists on our production S3 systems. For example, you might get throttled for whatever your account we have. We have at various places have a backup policy, like you can have your cache somewhere on the Redis or on the MySQL or Cassandra. Only go for S3 when you actually need it. Internally, we don't use, all of our core flows is not dependent on S3. We are pretty critical on time latencies. Like, for example, we say most of our touch latencies are less than 400 milliseconds, which means we can't go to S3. Internally, there is a blob storage as well. Uber actually built one of the blob storage. Right now, we kind of use S3 only for backup. A little more introduction about integration test frameworks that we kind of build. For example, if I'm a service owner, which I'm trying to test, what we ended up building is a networking agent, which we call router. It kind of understands the environment where you are in, whether you're in developer, laptop, or CI, or staging, or production. It kind of knows how to route the request to the rest of the world. For example, if you have a read and write request, you can understand to send the write request to the staging cluster of Cassandra, whereas read request you can actually share with the production traffic. This kind of elevates us some of the problems, like we can actually run in various kinds of environments, but we can have a similar Uber view of the world to actually do the testing. And at Uber, earlier Prabhu mentioned, we kind of use a lot of peripheral systems like various storages. That comes up with a problem. How do you actually provide, how do you bring up all those dependencies on your local laptop in order to do testing? And if you're also going over network, now network latencies becomes important. How do we bridge those gaps where some of the services wants to test pretty quickly, get the feedback pretty quickly, but they still wanted to talk to a system, which means can we bring up some of those Docker containers locally on the laptop app so that I can quickly talk to my local peripheral system and stuff going on the network. So our platform kind of exposes a declarative YAML where service owner can decide which way they wanted to go. That way they can choose what they wanted. The other thing is I put Stubbing Service as well, which I'm going to talk a little bit later. But the idea is if you want to avoid where your network latencies, you can actually do a lot of capture and replay, mocking some of your responses. So you can be in the world where some of your tests are pretty quick to get a high confidence. And you can also have some more tests where they can go over network and get you more meaningful feedback as well. Yeah, some of the problems I talked about is how do we make sure there's multi-tenancy on every service in the data center. This is somewhere we are trying to enforce through some of those tracing tools where every request is tagged, every request is propagated down. Now the problem comes is if you're trying to use some of the open source, MySQL or Cassandra, they might not have the notion of what does test data mean. Do we have a test namespace or a test table? How to introduce those changes into client library? If the client libraries are open source, how do you actually manage between those two? It becomes a challenge at most of the systems. And test accounts, if you have to simulate any of the business case, you have test drivers, test riders, test vehicles, pretty much everything. And if I'm a service owner, I don't want to know a lot of all of these, but I just want to quickly write a business use case that I can test for my services. So we made a lot of things easier for frameworks that people can create some of these, curate some of these, and they can just write their business logic in order to see the whole end-to-end test trip flow. And we take test accounts very seriously so that every request is tagged with it, and it's propagated down pretty much as all of your leaf systems like Kafka or some kind of S3 systems there. We wanted to tag all of this with this test account so we know this data is coming from test traffic versus production traffic so that you can build interesting tooling on top of it. The other challenging is writes to shadow storage. For example, if I'm getting test requests and product requests, I don't want to pollute my production database, where you can do some of the shadowing techniques where your writes could be sent to a totally different namespace or tables. At a later point of time, you can actually compare the change that you actually tested, if it modified any of the data before you can actually roll out. We have some of these inbuilt into the infrastructure itself. So the interesting thing is we execute all of this locally to give a very meaningful feedback for the service owner. We also do run the same thing in CI so that you get much better feedback. Container isolation, for example, if my servers decide to have a lot of local laptop dependencies, we wanted to make sure there is isolation at all the places so that we discover issues. We use heavily containers even on the laptop and on the Jenkins so that you have your entire view so that the tests, all of them have their own isolation. So we also published to your test registry. This is slightly interesting in the sense, let's say you have a whole call graph and you are at one single node and you're trying to test a change for that node. For some reason, it seems maybe there is a regression somewhere in the downstream nodes or upstream nodes. The interesting idea here is once we know a build pass-through integration test, we can put that somewhere in the cloud, and slowly we can take one of the node in the graph, replace this with the binary, and figure out what is the dependency that actually caused degradation. So we could do some interesting things around test registry. This is something I was talking about earlier about pretty much most of our Leaf peripheral systems kind of support totally different way of separating out your writes so that you don't pollute and you can actually do comparisons. Some of the challenges here is how do you bring that quickly without me being a service owner doesn't have to learn a lot about Cassandra or MySQL. The challenge is can you give me one single command and bring the whole world up. Some of the other challenges is we wanted to make sure there is isolation for various tests. So if you get a feedback, you know exactly what to act upon rather than spending hours of time to debug through those logs. Yeah, this is Stubbing Service. Let's say if you have a call graph, let's say if you have a business ride, which you are trying to take a trip, and it kind of talks to a whole set of services. Some of the interesting ideas is can we actually capture and record? That means if you can capture every request that's going through service, now you can take all of those records and you can actually replay and put your modified service in a Jenkins environment and see if something has broken or not. This would be super helpful if you have some of the config changes or schema changes to test. You can get much more meaningful feedback much earlier. There are some more interesting things that we were thinking of doing is at any point of node, if you know what's the input and what's the output, that means I can automatically generate tests based on the input and test so that even developer doesn't have to write any of these downstream tests for microservices. This is something that doesn't exist, but we are planning to do. Some of the other problems that comes with the fixtures, let's say if you have the capture and replay and some of your tests are using this, there is a meaningful feedback that you can get off it, but there are challenges that it can quickly get outdated and you might not discover the real scenarios. We kind of leave that option to a service owner to choose how much they wanted with this approach versus the real approach of integration testing so that they can cover both kinds of scenarios. Load testing, as I mentioned earlier, today, pretty much every team, it's become a very rhythm at SRE place where we use load testing for every service to make sure we are, whatever the XRPS that we are promising, that service is not degraded. Not only for the service, we take that to across data center level and see what's the capacity that we need. We kind of run these tests and see what we need to for next 90 days. Based on that, we do a lot of planning about what exactly we need. Resiliency testing, this is something where Dan is going to cover a little more details about it, but basically what I wanted to touch upon is we do a lot of network simulations, resource pressure testing on your production service, which means we need to be extremely careful. We need to have things built into the system that we can automatically contain if there is any risk. We built a whole lot of infrastructure around it. We also used to simulate some of the data center migrations. If we can simulate some of those to see if it breaks any of the business flows, even before migrating some of the stuff. We are at a point where we actually run this continuously in our production systems. So pretty much as a service owner, they're not aware of it until something breaks down. And then they get a more detail about why it breaks down to go and take a look at it. The important problem here is, for example, if I'm trying to run a disruption, how do I make sure the service is not deviating from steady state, which means we need to understand what's the steady state and how do we stop it when we know something is going out of bound. These are some of the challenges that we had here to solve. The other one is the external public API. Today, we wanted to guarantee whatever availability or error rate that we promise. We actually run our external probers framework in the Google Cloud and AWS to make sure none of the endpoints are down. Something are not working, we would get to know much earlier than any of our customer notices. And not only just the endpoints, the business endpoints, but we also make sure we have scenario-based endpoints, which means like I can take a trip, I can complete the trip, and I get charged. And we make sure none of those scenarios are also broken as part of this external prober testing. Test tenancy, we heavily use test tenancy. We wanted to make sure when we are doing, you don't have a test rider that got dispatched to a real driver. So we want to have isolation at pretty much all the places. This is the manual testing. This is the Uber Studio where I wanted to talk about it. We have internal, this one where you can actually pick a geography location and drop a couple of cars, drop a couple of drivers and request for a rider and see what's the route it actually takes. This will be super helpful if you kind of see some of the corner cases. The interesting thing is you can actually capture this in a file, and you can actually share with other engineers who can actually look at it to see what went wrong.